Welcome back to my channel. My name is Prachi Sharma, and in this session right now we are working on a fresh sample paper. I have not shared this sample paper on Telegram channel or with any of the students yet. This is a fresh sample paper that we are working on. I won't be writing all the answers on the screen. It would be more like a discussion like we do in important question videos. But there will be certain questions that I will write the whole equation, and for numericals or some important part, I may even solve the question on the screen. So if that is something you are interested in, well and good, you can solve along with me. If that is something you don't want, you can fast forward in that question and continue from the next one. My target is to help all the type of students, someone who is a fast pacer as well as someone who needs the numericals to be solved on the screen. So without wasting any time, let's get started. The question paper and the answer script that we discussed in the session today, both of them will be available in the description box as well as they will be available on the Telegram channel. So make sure that you download them and have a good look at that. So without wasting any time, let's get started. Alright students, let's get started with today's session. One important thing is that I'm trying my best to keep this video as short as possible, because I understand it is your examination time going on, and my target is that in less amount of time you are able to go through more content. So please stay with me as I'm trying to make the pace of this video a little higher. So let's get started with the first question. Choose the correct answers from the options given below. The number of electrons present in the valence shell of a halogen is. So halogens belong to the 7th group. So therefore their number of valence shell is 7. Number of electrons present in the valence shell is 7. Next is the metal oxide which can react with acid as well as an alkali is what? So these oxides are known as amphoteric oxides. These oxides will react with acid as well as an alkali to give you salt plus water. The answer for here, this one, is aluminium oxide, which is a great example of an amphoteric oxide. The reducing agent used for the reduction of copper oxide to copper. So if you react copper oxide with hydrogen, hydrogen will combine with oxygen and give you water, and you will be left with copper only. So the answer for this one will be hydrogen. Dilute sulfuric acid will produce a white PPT when added to a solution of what? So generally, if you think about the test for dilute sulfuric acid, it is barium chloride. That if you react it with barium chloride, you end up getting a white PPT, which is insoluble in all mineral acids. So that's a test for sulfuric acid. But along with that, it is also lead nitrate, with which you can get a white PPT. So the answer will be lead nitrate. Moving on to the next question. The formation of 1,2-dibromoethane from ethene and bromine is an example of what? It is an example of addition reaction, because what happens in addition reaction is that the bond breaks and an additional compound gets added there. Let me make the equation and show you. So what happens in this case is, let's say you have CH2, okay. So you have 2 hydrogens here. So what will happen is one of the bonds will break. So this will make space. So CH2, and over here your bromine will get connected. So this is addition reaction. Let's move to the next part. The IUPAC name of dimethyl ether is methoxymethane. That is B. Then next part is the unsaturated hydrocarbons undergo an addition reaction. A metal present in cryolite other than sodium is what? So what is the formula for cryolite? That is Na3Al F6. So other than sodium you have aluminium present. So your answer will be aluminium. Nitrogen used in Haber's process is obtained from. So it is obtained from fractional distillation of liquid air. This we study when we discuss Haber's process, because it's important for you to understand where the reactants are coming from. So it is clearly mentioned there, fractional distillation of liquid air gives you the nitrogen for Haber's process. The acid which can produce carbon from cane sugar. So the answer should be concentrated sulfuric acid. Why is that? Because sulfuric acid when added to sugar gives you a black porous mass which is of carbon. Okay. Let's move to the next one. Which of the following acids was formerly known as aqua fortis? So the answer is nitric acid. The common name or the initial name for aqua fortis was nitric acid. The oxidized product obtained on action of concentrated nitric acid on carbon is carbon dioxide. Identify the statement that does not describe the property of alkenes. So they are unsaturated hydrocarbons. They decolorize bromine water. They can undergo addition as well as substitution reaction. No. So that is not the property of alkenes. They can undergo combustion with oxygen forming carbon dioxide and water. That is correct. Then sulfur dioxide turns acidified potassium dichromate solution green. Which of the following property was shown by sulfur dioxide in this process? So the answer is reducing property. It is showing reducing property. I am not writing the equations here because that will unnecessarily lengthen the video. Let's move to the 15th part. Hydrogen chloride gas is not collected over water since it is a covalent in nature, it is ionic in nature, it is highly soluble in nature. That is why. Let's move to question number 2. From the formula listed below, choose one. Choose one in each case corresponding to the salt having given in the description. An acid salt. An acid salt should always have hydrogen in that. So if you look at all your options and you look for hydrogen, so your answer is only one. That is NaHSO4. That is your acid salt. An insoluble chloride. So insoluble chloride is AgCl. We have already known that. We know that because we have studied that in the chapter. On treating with concentrated sulfuric acid, this salt changes from blue to white. So this relation should be with copper sulfate. Okay. And it is changing from blue to white. And it is being reacted with concentrated sulfuric acid. So what happens in this case is that concentrated sulfuric acid is a dehydrating agent. It has great affinity for water. So when you add water of crystallization like copper sulfate with water of crystallization in sulfuric acid, it will end up absorbing water. So your blue color of copper sulfate will turn to white. So in this case your answer will be copper sulfate with water. So CuSO4.5H2O. That is your answer for the third part. Now next is, on heating the salt changes from green to black. So that will be copper carbonate, because copper carbonate converts from green to black. This salt gives nitrogen dioxide on heating. So nitrogen dioxide, that means NO2. So you should be having a nitrate, that you react the nitrate with something or you heat that nitrate, it decomposes to give you nitrogen dioxide. So if you look at your options and you look for nitrate, you have two nitrates. You have potassium nitrate and lead nitrate. So your answer should be lead nitrate. PbNO3 whole twice. Alright students, let's get started with the second part, that is fill in the blanks. So the first part says soluble salts are prepared by dash, whereas insoluble salts are prepared by dash. So soluble salts are generally prepared by neutralization reaction, whereas insoluble salts are prepared by precipitation reaction. Let's move to the second part, B, that is hygroscopic substances are also called as drying agents because they have great affinity for water. Next is dash is a green colored insoluble salt. So that is copper carbonate. D part is iron chloride is stored in airtight bottles because it is deliquescent substance. That means if left in open air, it has a tendency to vaporize. E, dash indicators can differentiate between the acidic or basic solutions of different pH values, that is universal indicators. Let's move to the third question. Some word or words are missing, written wrong in the following statement. You are required to rewrite the statement in the correct form using the appropriate word or words. So the first is magnesium reacts with water to liberate hydrogen and magnesium oxide. So magnesium does not react with water, it reacts with steam. So it reacts with steam. When manganese dioxide is heated with concentrated HCl, a greenish yellow hydrogen gas is produced. So greenish yellow chlorine gas is produced. Metallurgy deals with production of metals. No, metallurgy deals with production and extraction of metals. Ethyl chloride reacts with potassium hydroxide to give ethyl alcohol. So ethyl chloride reacts with aqueous potassium hydroxide to give ethyl alcohol. Now the last is, during electrolysis, oxidation occurs at the cathode. No, oxidation occurs at the anode. Let's move to the next part. Give the chemical tests between the following pairs. Okay, so in this case what you can do is, you can make a chart. You can use ammonium hydroxide, whatever you are using the test as. So let me show you how you can write this in the exam. So you make a chart like this. The first would be of course 1, 2, 3. The second, you can use the reagent. Then in the next section you can use the first one, that is given iron 2 sulfate and then iron 3 sulfate. So how you will go about this is, first you write the reagent and then tell the difference. Then for the next one again write the reagent and then tell the difference between the compounds. Okay, so let's start with the first one. So I am using ammonium hydroxide for iron 2 sulfate and iron 3 sulfate. For iron 2 sulfate we get a dirty green insoluble precipitate, and for iron 3 sulfate we get a reddish brown insoluble precipitate. Now these diagrams or these charts are already available in the chapter Analytical Chemistry, which I have already discussed on the channel. So you can check out the charts from there. Now next is difference between zinc sulfate and zinc chloride. So how you can differentiate between them is, you can use barium chloride. With zinc sulfate you get a white PPT which is insoluble in all mineral acids, whereas with zinc chloride it will not show any reaction. Now let's come on lead salt and zinc salt. You can differentiate between by using excess of ammonium hydroxide. When you have excess of ammonium hydroxide, first of all both of them will give you a white PPT. Lead will give you a chalky white PPT. Zinc will give you a gelatinous white PPT. By using excess ammonium hydroxide, lead has an insoluble salt and the zinc dissolves in excess of ammonium hydroxide. Let's move to D, calcium nitrate and calcium chloride. So you can use silver nitrate solution here. This was the part discussed in nitric acid. So by adding silver nitrate solution, what will happen is, for calcium nitrate you will have no visible reaction, and for calcium chloride you will have a white PPT which is soluble in excess of ammonium hydroxide. Now next is copper sulfate and iron 2 sulfate. You can use ammonium hydroxide here. For copper sulfate you get a blue PPT which dissolves in excess of ammonium hydroxide and gives you a deep blue inky solution. Now in the exam it's not necessary that you mention the entire thing. Even if you mention, let's say for example you said let me use ammonium hydroxide, for copper sulfate you say it gives a blue PPT. That's it. It's not necessary that you give all the detail that it will be soluble in excess or not soluble in excess. You don't need all that if you are using your reagent as ammonium hydroxide. If you are using your reagent as excess of ammonium hydroxide, then you have to give the color of the PPT as well as its solubility or insolubility in excess. Okay, so I hope you understand the difference. Then iron 2 sulfate will give you a dirty green PPT which is insoluble in excess of ammonium hydroxide. Now let's move to the next part. In this case you are supposed to make the isomers. Okay, so the first one is chain isomer. So chain isomers are pretty easy. Let me draw them here. So you have pentane. So 1, 2, 3, 4, 5, balance the hydrogens. The next one would be 1, 2, 3, 4. One of the carbon will here. Then the next one would be 1, 2, 3, and the carbons will be here. You have to balance the hydrogens. Now you get the marks for the names also. So the first one is just pentane, sorry, N-pentane. The next one is isopentane, and the third one is neopentane. You get marks for the names also. Next is draw position isomers of C4H6. So C4H6, let's make that. So I'm just making it that is visible now. Okay, so I'm making it right here. So you have C, C, double bond C and a single bond. Let me just make it like this in the corner. So when I'm using position isomer, so my double bond will be moving. So double bond is at the end. So this is what but1-ine. I'll move the double bond in the center. So this is what but2-ine. This is your position isomers for C4H6. Let's move to the next part, that is give balanced chemical equations for the following reactions. Laboratory preparation of ammonia using ammonium salt. So if you are using ammonium salt, let's use ammonium chloride. So that will be NH4Cl plus CaOH whole twice, and that will give you CaCl2 plus water plus ammonia gas. This is lab preparation of ammonia using ammonia salt. Now reaction of ammonia with excess chlorine. A lot of students miss this information. Ammonia reacts differently with excess chlorine and it gives different products when ammonia is in excess itself. So you have to make sure you read the entire question properly. So reaction of ammonia with excess chlorine. So what will happen in this case is you will have ammonia, so NH3 plus chlorine, and mention excess there, and this will end up giving you HCl plus NCl3, that is nitrogen trichloride. Now next part is reaction of ammonia with sulfuric acid. Let me write the reaction right here. So ammonia with sulfuric acid, H2SO4, will give you NH4 whole twice SO4. So this is your reaction. Now this concludes our section A. Okay students, let's move ahead to section B. So section B, question number 3. State the relevant reason for which for each of the following. Low temperature favors the synthesis of ammonia in Haber's process. Let me zoom in a little. Low temperature favors the ammonia in process. So the reason is that this particular reaction, that is the preparation of ammonia, it's an exothermic process. So it is better that you maintain low temperature, otherwise the heat or the amount of heat generated in the entire process can get out of hand. So to avoid that and to keep it in control, we use it at low temperature. So what will you write in the exam? You will say that the preparation of ammonia or synthesis of ammonia is an exothermic process. Therefore, it is advised to maintain low temperature in the entire Haber's process. Second part, nitric acid acts as an oxidizing agent. The reason for this is that when nitric acid decomposes, what is decomposition? You have nitric acid, you keep providing heat to it. When it decomposes, it produces nascent oxygen, and this nascent oxygen easily oxidizes any element that you put along with that. That is the reason nitric acid is a good oxidizing agent. Let's move to the second part. Fill in the blanks from the choices given in brackets. Methane burns in air with a dash to form carbon dioxide and water vapor. So methane is an alkane. Alkanes always, they are very good fuels. They always burn with a bluish non-soothy flame. How you can remember this is that cylinder that we use, the LPG cylinder that we use, not LPG, the CNG cylinder that we use in our kitchen, if you would have ever noticed the flame, that is blue in color, and it will change in color if no proper oxygen is provided. If your vessel kept over the burner is very big and oxygen is not reaching it properly, then the color changes to slightly yellowish. That's a different case. But if you look at just the flame, if you just switch it on, it's a blue flame. So that is also a compound, that is a alkane. Okay, so methane burns with a bluish non-soothy flame. Second part, Magnesium is an alloy of copper and zinc, aluminium and magnesium. The answer is aluminium and magnesium. That is what magnesium is made up of. Let's move to the third part. The following questions are pertaining to the lab preparation of hydrogen chloride gas. Write the equation for its preparation, mentioning the conditions required. Whether they ask you the condition or not, you are supposed to write the condition when you are writing any equation. So let me quickly write the equation right here. So this is NaCl plus H2SO4 gives NaHSO4 plus HCl, and this is below 200 degrees Celsius. Let's move to the next one. Name the drying agent used and justify your choice. The drying agent we use for production of HCl is concentrated sulfuric acid, and what is the reason for that is that concentrated sulfuric acid has great affinity for water, so it easily absorbs any extra moisture or water, and therefore it is a very good drying agent. Another type of question can come here, that why let's say quicklime or phosphorus pentoxide, why other materials or other compounds are not used as drying agents. The reason for that is that HCl gas will end up reacting with them instead of letting them absorb just the moisture. So that is the reason we don't use other elements. We only focus on concentrated sulfuric acid as a drying agent. Next is state a safety precaution you would take during the preparation of hydrochloric acid. So when in the entire process you are also making the acid towards the end, then you use an inverted funnel arrangement. And why do you use inverted funnel arrangement? That is because HCl is highly soluble in water, and the speed with which it dissolves in water is comparatively higher than its production. So what would happen is that if you just use a tube, back suction of water can happen, and the beaker right before that is sulfuric acid. So you can end up having a bigger accident rather than just making HCl acid. So it is always suggested use an inverted funnel arrangement so that it increases the surface area for the absorption of HCl gas, and that also avoids back suction of water. Let's move to the next one. Copper sulfate solution is electrolyzed using copper electrodes. Study the diagram given below and answer the questions that follows. Which electrode to your left or right is known as the oxidizing electrode, and why? The electrode on left is known as oxidizing electrode. So this is oxidizing electrode. That is because oxidation takes place at this electrode. That is the reason that is an oxidizing electrode. Write the equation representing the reactions that occur. So we'll write both of them, what is happening at cathode and what is happening at anode. So let me write that. Use this space at anode. You'll say Cu minus 2 electrons give you Cu2 plus. At cathode you will have Cu2 plus 2 electrons giving you Cu. State two appropriate observations for the above electrolysis reaction. So the first is that reddish brown copper is deposited at cathode, so you can see that layer being formed. The second observation is that the bluish color of your electrolyte does not fade away, it stays as is till the end of the process. So these are the two main observations. Let's move to the next question. Question number 4. A gaseous hydrocarbon. So these two are numericals. I will have to do these numericals towards the end. Alright, so we'll do these two numericals towards the end of the screen so that I have the questions also written there. Let's move to the third part. The following table shows the tests a student performed on 3 different aqueous solutions, which are X, Y, Z and W. Based on the observations provided, identify the cation present. So this is from analytical chemistry. A lot of students are scared about learning the equations of analytical chemistry, but I always say that even if you are not good with equations and you just understand the chapter, and you can check that out, the video on my channel. If you just understand the color of the PPTs formed, what is happening in excess, whether they are soluble or insoluble, you can still answer about 80% of analytical questions. Only 20% of this chapter will ask you equations. Other 80% are just based on the color, the conclusion, identifying the cation. So make sure that you do not skip this chapter just because you're scared of equations. So let's just start with that. The chemical test they have done is, to solution X, ammonium hydroxide is added in minimum quantity first and then in excess. A dirty white PPT is formed which dissolves in excess to form a clear solution. So a dirty white PPT which is soluble in excess of ammonium hydroxide, that is your given information here. So this should be your zinc. So that means your conclusion is Zn2 plus ions. If you're still confused how I'm getting this, please go ahead and check out the analytical chemistry video, mind mapping, not the mind mapping one, but the one in which I have taught. There are 3 videos. Now next is, to solution Y, ammonium hydroxide is added in minimum quantity first and then in excess. If you map it from the chart that I have taught, a pale blue precipitate is formed which dissolves in excess to form clear inky blue solution. Whenever you see blue, you're not sure about it, you don't have enough time, please write copper, because you only have copper which is bluish in color in your syllabus in 10th grade. So your answer is Cu2+. To solution W, a small quantity of sodium hydroxide solution is added and then in excess, a white precipitate is formed which remains insoluble. So for sodium hydroxide, a white PPT which is insoluble. All of these things indicate towards calcium. So calcium ions. Let's move to the next one. Identify the gas in the following. Gas produced by the action of nitric acid and copper. Students, I have told you this even when I was doing important questions of nitric acid. They have majority of the cases they have asked nitric acid with copper in some form. Whether they will ask you equation, whether they will ask you what will happen. So please make sure that you study that. So concentrated nitric acid and copper. So when that happens, you get nitrogen dioxide. So your answer will be nitrogen dioxide. If you had dilute nitric acid, you will get nitric oxide. Okay. In this case, you get nitrogen dioxide. Let's move to the next one. Gas used as illuminating country houses. So that is ethine. Ethine gas is used. Third, gas which does not conduct electricity in liquid state but conducts electricity when dissolved in water is hydrogen chloride gas. So hydrogen chloride. And why does that happen? That is because when hydrogen chloride is in liquid form, it does not have any free ions. And that happens, the dissociation happens when you add water to it. So as long as there is no water present, no dissociation of ions happen, therefore no conduction of electricity happens. Let's move to question number 5. Write balanced chemical equations for each of the following when excess of ammonia is treated with chlorine. Another important thing here is that I have seen a lot of students make this mistake. They miss out the word excess of ammonia. So there are 2 different equations for this particular concept. One is excess ammonia, one is excess chlorine. So make sure that you pay attention on which one you are working with. So for example, right now we are working with excess of ammonia. So let me write the equation for you. So that will be NH3 plus chlorine. That will give you NH4Cl plus nitrogen gas. And then you can later balance it out. Now next is an equation to illustrate the reducing nature of ammonia. So in reducing nature of ammonia, you can use any of the equations of your choice. Right now I am using ammonia's reaction with copper oxide. So let me find some space here. So copper oxide, so ammonia plus copper oxide will give me copper plus water plus nitrogen gas. And that's it. Now next is, of the 2 gases, ammonia and hydrogen chloride, which is more dense? Name the method of collection for these gases. So hydrogen chloride gas is more denser. And how do we know that? Because hydrogen chloride is collected by upward displacement of air. That means air moves out and hydrogen chloride settles in. Whereas ammonia is collected by downward displacement of air. That means you have a funnel. As ammonia rises up, air gets out. Okay, so downward displacement. So let's move to the next one. Next question is, answer the following questions. Name the metal which is found abundantly in Earth's crust. That is aluminium, the most abundant metal. So aluminium. State one observation when a zinc granule is added to copper sulfate solution. So a red metal starts precipitating and the blue color of the copper sulfate solution fades due to the formation of colorless zinc sulfate. Okay, so I hope that observation is clear. Next is, give reason why copper is used to make hot water tanks and not steel. So this is because copper is a good conductor of heat, whereas steel, it is an alloy and it is not that good at conducting heat. Next, all right students, let's move to the fourth part. This question says, give reasons why. So the first is, metals act as reducing agent. So what are reducing agents? So reducing agents are generally elements or compounds which have a tendency to lose electrons. When we think about metals, metals have the valency or the number of valence electrons as 1, 2 or 3. Therefore, it is easier for them to donate electrons and attain the closest noble gas configuration. Due to this property of metals, they are considered as good reducing agents. Second part, carbon tetrachloride is a non-electrolyte. So carbon tetrachloride is a covalent compound and does not form ions. Due to the absence of ions, it is a non-electrolyte. That means there won't be any conduction of electricity because of the absence of ions. The third is, the temperature of the reaction mixture of nitric acid not to be allowed to rise above 200 degrees Celsius. So the main reason for this is that nitric acid, or you can say, nitric acid. So when you keep rising the temperature, nitric acid that is being generated in the form of vapors, it gets decomposed. And when it gets decomposed, it ends up forming sodium sulfate or potassium sulfate, depending on what ingredients you're using, what reactants you're using. And due to this, the entire formation of nitric acid vapors is obstructed because sodium sulfate or potassium sulfate, these are sticky substances and will get stuck to the reactants and will not let the production of nitric acid happen smoothly. Therefore, it is suggested that the temperature should not go above 200 degrees Celsius. Next question is question number 6. In the contact process for the manufacture of sulfuric acid, give the equations for the conversion of sulfur trioxide to sulfuric acid. So this is easy. You have SO3, that is sodium trifluoride. You add sulfuric acid to that, you get oleum. What is oleum? H2S2O7. In oleum, add water, that gives you H2SO4. Let me write the equations for you. Okay, I have space here. So SO3, sodium trifluoride, sulfur trifluoride, plus H2SO4 will give you H2S2O7. This is oleum. Now H2S2O7 plus water will give you H2SO4. So these are your equations. Let's move to the next part. They are saying, state any 2 reasons why SO3 is not directly dissolved in water to form sulfuric acid. Okay, I'll give you 3 reasons. The first reason is, this reaction is highly exothermic in nature. So even when you try to mix it, a lot of heat will suddenly come out and it can cause accidents and burns to someone standing close by. That is one. The second is, SO3 does not form a homogeneous mixture with water. So what is homogeneous? A consistent mixture. It does not form a consistent mixture with water. The third is, a dense fog is created. So as you try to mix it, a dense fog comes out of sulfuric acid particles. And once sulfuric acid particles are in the atmosphere, it can cause disease, that is phossy jaw. So it can cause a disease, phossy jaw. Let's move to the next question. Write balanced chemical equations for the following when excess of ammonia is treated with chlorine. This is a repeated question. This is already a part of one of the questions that we have discussed. So when excess of ammonia is treated with chlorine, let me write the equation for you real quick. So you have ammonia plus chlorine, and when you have ammonia in excess, you get ammonium chloride NH4Cl plus nitrogen gas. Now dry chlorine is passed over heated iron. So chlorine plus iron will give you FeCl3. Ethanol under high pressure and low temperature is treated with acidified potassium dichromate. Okay, so what happens is ethanol, so that will be C2H5OH plus nascent oxygen in the presence of potassium dichromate. So K2Cr2O7, and this is acidified. What will you end up getting? You will end up getting CH3COOH plus water. So that is your equation for this. I have already taught this equation in the chapter Organic Chemistry. So if you have doubts, you can check that out. Let's move to the fourth part. State from the list given A to C one substance in each case which matches the description given in parts A to B. A, B and C. Okay, so we have iron chloride, nitroso iron sulfate, chromium sulfate. Alright. So when we look at this, the first thing that you need to understand is nitroso iron sulfate is related to the brown ring test. So if you see brown ring test anywhere, nitroso iron sulfate is gonna go there. Then iron chloride is a deliquescent compound. That means it vaporizes when left in open air. So that is, it's a deliquescent substance. So let's quickly see. A compound reversible for the form of ring for the brown ring during the brown ring test of nitrate ion. So it should not be reversible, it should be responsible. This is responsible. A compound responsible for the brown ring during the brown ring test in the nitrate ion test is nitroso iron sulfate. So this goes B. A compound which is insoluble in water but soluble in hot water. None of the options match. I think this question is the one that had a mistake. This should not be chromium sulfate here. Your C should be lead chloride. Because one of the question was wrong printed in my book. So it should be lead chloride. A compound which is insoluble in cold water but soluble in hot water is lead chloride. A compound which is deliquescent is iron chloride. Okay students, let's move to question number 7. State two relevant observations for ammonium hydroxide solution is added to zinc nitrate solution slowly and then in access. So when you add it slowly, you get a white PPT because it is zinc. So when you have zinc, you get a white PPT of zinc hydroxide. Okay, ZnOH whole twice. So once you get that, then as you keep adding the solution in access, that is, as you increase ammonium hydroxide and reach up to access, this particular PPT dissolves. Okay, so that is your observation. So first observation is that you get the PPT. Second observation is it gets dissolved in excess. Two observations. Next is write the IUPAC name for the following. Okay students, if you're facing issues with IUPAC naming, I have a very short video, only 20-minute video of IUPAC naming in which I have completely from scratch taught everything in detail. So make sure that you check that out if you're struggling with IUPAC naming still. Let's look at this question. Okay, so you have 1, 2, 3, 4, 5, 6. That means you're talking about hex. HEX, hex. So you're talking about hex, and then at the third carbon you have a double bond. So hex 3, actually hex 2-ene because it's the second carbon. So let's start with that, hex 2-ene. Okay, so first one part is done. Then at the third carbon you have a methyl group. Okay, that means you have a CH3. So your answer will become 3-methyl hex 2-ene. So 3-methyl hex 2-ene. That's your answer. Let's move to the next one. So 1, 2, 3. Okay, we are talking about prop. Okay, so prop. And this is an aldehyde because we have a double bond O and an H on the corner. So this is a propanol. So prop A null. Next is alkenes are dash series of dash hydrocarbons. They differ from alkenes due to the presence of dash bonds. Okay, let's see. So alkenes are the homologous series. So it's a homologous series of unsaturated hydrocarbons. They differ from alkanes due to the presence of double bonds. Now next is write structural formula of the compound formed when mole of ethyne reacts with 1 mole of hydrogen gas. Okay, I know this is a slightly confusing question, but what you have to understand is when they say 1 mole of ethyne and 1 mole of hydrogen, don't get confused. What is 1 mole of ethyne is? Just take one molecule of ethyne. Okay, what is ethyne? So meth, eth. Okay, 2 carbons, 1, 2, YNE, that means triple bond. Okay, so this is what you have. They are adding 1 mole of hydrogen gas here. That means they are adding H2. 2 hydrogen atoms are being added. So what will happen is, out of 3 bonds, 1 of the bond will break and 2 hydrogens will get added to 1 carbon each. So what will come out of this is nothing but an addition reaction. So plus hydrogen, this will give you C, double bond C, and hydrogens will get added here, and rest of course you can balance. So this is what the reaction would look like, but they are not asking the entire reaction, they are only asking this product. So this is what it's supposed to make. Let's read the question again. Write structural formula of the compound formed when 1 mole of ethyne reacts with 1 mole of hydrogen gas. This is a very simple question, just the language of the question is a bit tricky. Next is name the catalyst used in the above reaction, that is nickel. Write temperature at which the reaction mentioned occurs, that is 200 degrees Celsius. Next is at which electrode aluminium is preferably discharged during the electrolytic reduction of fused aluminum. So aluminium being lower in electrochemical series is preferably discharged at cathode during electrolytic reduction of fused aluminum. Okay, so at cathode. Give any 2 uses of duralium. So duralium is generally used in making lightweight tools, and second, it is used in manufacturing of the bodies of aircrafts. So 2 uses. Next is draw the structural formula of the following compound. You have butane and pentene. Okay, so bute means 4. So the first thing you will do is you will make 4 carbons. So 1, 2, 3, 4. Once you have that, then they are talking about YNE. So you are talking about triple bond. Since they have not mentioned any position of the triple bond, I suggest to go with the corner ones. So just make a triple bond here, and other than that, just balance out the hydrogens. So you will just need 1 hydrogen here. This does not need a hydrogen. 2 hydrogens here, and 3 hydrogens here, and that's it. Let's move to the next one. Pentene. Okay, so pent is 5. So 1, 2, 3, 4, 5. And ENE means a double bond. So just make a double bond here and just balance out the rest of the hydrogens. Next is the elements of one short period of the periodic table are given below in the order from left to right. So you have lithium, beryllium, boron, carbon, oxygen, fluorine, neon. To which period do these elements belong? They belong to the second period. One element of this period is missing. Which is the missing element and where should it be placed? Students, whenever you get such a question in one sentence, but it is asking you 2 questions, please answer them separately. Do not just write, okay, nitrogen is missing and just mention that, okay, this is where nitrogen should be placed. You will lose marks for that. So make sure that if they have asked you 2 separate questions, you write 2 separate sentences for those answers. So the first answer will be nitrogen is the missing element. The second question is where should it be placed? It should be placed between carbon and oxygen. So it should come right here. Now third question. Which one of the elements in this period show the property of catenation? Carbon shows the property of catenation. Next question. Name the following substances. A yellow non-metal formed when hydrogen sulfide gas is passed through concentrated acid. So your answer will be sulfur. A hydrocarbon which on catalytic hydrogenation gives a saturated hydrocarbon. In this case, you can give any name of any alkene, but for now we'll go with the answer ethene. Because they have asked a very general question, so any of the alkenes will be the correct answer. But you have to mention the name. So either it will be ethene, propene, butene, but name, not alkene, but the name of the compound. Next is a strong but non-volatile mineral acid is sulfuric acid. Alright students, let's move to the numericals because they are pending. I have stuck the question right here on the screen. The second part of the question is not in the syllabus this year. You do not have percentages of compounds. If your teacher has done that, let me know in the comment box. I will help you solve it. But according to my understanding of the syllabus, this is not in the syllabus. Let's do the first question. A gaseous hydrocarbon contains 82.7. So I have already made the table for calculating empirical formula. Because for calculating molecular formula, you need to first calculate empirical formula and then you go step by step. So let's look at this. So the first is they are saying a hydrocarbon contains 82.76% of carbon. So your carbon is 82.76%. If carbon is that much, hydrogen will be 100 minus 82.76. So that will be 17.24. 17.24%. What is the atomic weight for carbon? It is 12. For hydrogen, it is 1. Relative number of atoms. So how do we calculate that? 82.76 divided by 12. 17.24 divided by 1. So I'm just quickly gonna use a calculator for this. This is gonna come out as 6.89 and this will be 17.24. Now which one, if you have a lot of numbers here, for now you just have carbon and hydrogen. Once you have a lot of elements, whichever is the smallest one, pick that up and divide all the other numbers with that. For example, in this case, the lower number is 6.89. So 6.89 divided by 6.89. 17.24 divided by 6.89. So in this case, the first one you will get 1. The second one, you will get 2.5. Okay. Now at this particular stage, students, I have seen a lot of students make a mistake. So when they are rounding off, what they will do is 1 will go as 1, 2.5 will go as 3. Do not do that. That's the wrong method of doing it. If ever you get a number, let's say you have n numbers, whenever you get a number that is 0.5, always multiply all of the numbers by 2. Okay, to get rid of the 0.5 value. So in this case, multiply both of them by 2. Okay, so 1 will become 2 and 2.5 will become 5. Okay, so this is how you're supposed to do that. If any number comes out as 0.5, multiply all the numbers by 2. So 2 and 5. So what will become your empirical formula? That will be C2H5. And once you have that, you can find the molecular weight. So 12 times 2 plus 1 times 5. So you have 24 plus 5, 29. Okay. Once you have the weight, how will you calculate, how will you use the vapor density? What is the value given? Vapor density is given as 29. So what do we know the formula? The formula is mass equals 2 times vapor density. Mass is given 29. And this is, no, mass is not given 29. Vapor density is given 29. So mass equals 2 times vapor density. So once you have that, so mass will be equals 2 times 29 and this will become 58. Now once you have this value, N equals molecular mass divided by empirical formula mass. And this N you will use to calculate your molecular formula. Once you have this, so N will be equal to 58 divided by empirical formula mass, which is 29. So your answer is 2. Now what is your molecular formula? Molecular formula equals empirical formula, the entire thing multiplied by N, whatever you got. In this case I got 2, so 2. So what will this become? This will become C2H5, right? C2H5 whole thing multiplied by 2. So your molecular formula will become C4H10 and that will be your molecular formula. Alright students, so this is where we conclude this session for today. So I have tried my best to keep this a fast-paced discussion on the sample paper. I will try and make sure that I post one more sample paper before your examination. So make sure that if you require another sample paper, you can let me know in the comment box. If I get more responses for another sample paper, I will make sure that I post another video. So stay tuned for more important question videos, students. Please do not miss those videos. I am putting a lot of effort in trying to check out all the last 10-year questions for those particular chapters and make the videos for you so that you save your time and in less amount of time you can do more content. So make sure that you stay tuned. Keep commenting in the box if you have any doubts and concerns, and also share the channel with your friends. Thank you so much. We'll catch up in the next session.